All right, here is the classwork you guys had today. We're going to go over the answers to these. So for number 1, it says f of x plus g of x. So start by plugging in these expressions. We would have 5x to the third minus 2x for f, and then plus g of x, which is 3x cubed. So now we combine the like terms. We have 5x to the third plus 3x to the third. That's 8x to the third. And then we would bring down minus 2x. Here's the final answer for number 1. Number 2, f of x minus g of x. With subtraction, we always have to be extra careful. Let's start by taking f. We have 5x to the third minus 2x minus 3x to the third. Now, if I had more than one term here, I would definitely put parentheses around it because I have to remember to distribute this. But because it's only one term, those parentheses are not needed. Although if you put them, you're not wrong either. So we would have 5x to the third minus 3x to the third. That's 2x to the third. And then bring down minus 2x. Here is your final answer for number 2. Number 3, we get into multiplying here. Multiplying can be tricky. So definitely we're going to need parentheses now. We're going to have 5x to the third is our f minus 2x. And then for g, we have 3x cubed. All right, here, because we have two terms, we're going to need to distribute both of them. So we have 5x to the third times 3x cubed. So times would be 15. And then the exponents here would add, so x to the 6th power. Then we have negative 2x times 3x to the third. That's, oh, sorry about that. That'd be negative 6. And then here we add the exponents, so that would be x to the 4th. Okay, when you don't see an exponent, put a 1. All right, and here's our final answer for number 3. Okay, now I'm going to go into number 4. I'm going to erase what I have so far just to make space. Okay, so for number 4, we have division. So we would have 5x to the third minus 2x being divided by 3x cubed. So what I would do here is I would divide them individually. So I'm dividing two things by 1 in the denominator, so I would have here 5x cubed over 3x cubed minus 2x over 3x cubed. Okay, in the first one, the x cubes will cancel, but I'm left with 5 over 3. And then here, I have the x's would subtract, right? But because I have the smaller one in the numerator, I'm going to have 2 over 3 x to the negative 2 here. Now that x to the negative 2 can't stay like that, so I would have to bring it down. So your final answer for number 4, a little complicated, is 5 over 3 minus 2 over 3 with that x squared like that. I don't have the answers in front of me, but I'm pretty sure that if you leave your answer like that, I'll double check. They're going to mark you correct. I don't think that you need to do all of this reducing. If you just leave your answer like where I have my arrow, I think you should be okay too.
We need somebody from registration in the main office. Somebody from registration in the main office.
All right, sorry, I'm in the hallway here making this video for you guys, and there's a lot of announcements and noise. So, and I'm wearing my mask. Hopefully you can hear me. All right, number 5 says f of g of x. All right, this is a composition, so I don't know if you guys remember how to do this, but I'll remind you. The f is the outside letter, right? That's the one that you want to write first. So 5x to the third power minus 2x. Now inside of x is going to go your g. Now this problem's a little tricky because there are two x's. So g is going to get replaced in both of these x's. So that could be a little tricky. Let's do this together here. So 5 will come down, and then we're going to have g, 3x to the third, and then bring down that the other 3 minus, now we're going to bring down 2, and then in the x is going to go the g, so 3x to the third. Okay, now sorry, a lot of noise in the background here. We're going to take this power of 3 and we're going to distribute it here and here. So that would be 27, and then here this would be x to the 9th. Remember, the rule is when the exponents are outside, you multiply. All right, so all together we would have here 5. We would combine this, 5 times 27. I don't have a calculator. I'm going to just do this in my head. That would be 135. Okay, x to the 9th. Now here this is just distributing, so this would be negative 6 x to the third. Nothing else I can do there. They're not like terms, so this is my final answer. Okay. All right, here we go, number 6.
So we'll probably do the playground too a little bit.
Okay, number 6 is g of f of x. So g gets written first. And in replace of this x is going our f. Okay? So now we have 3 parentheses 5x to the third minus 2x, and then bring over that power of 3. Believe it or not, you're actually done here. Can't do anything further. We can't distribute that 3 because of this subtraction sign. We can't bring in that exponent. And we're not about to cube this, so we're done. All right, so that's 1 through 6. Now let's get to 7 and 8. Remember, 9 was extra credit, so I'm not going to go over 9. I'm just going to go with 7 and 8 here. Okay. So number 7 says verify that f and g are inverse functions. So if you remember from inverse functions, you need to first do f of g of x. And your goal is for that to equal x. And then you're going to do it the other way around and also see if it's equal to x. So f we would write first. Sorry guys, hey, sorry. All right, so we're going to put in g here. And now g is x plus 7. I was saying sorry, by the way, to somebody else, not to this video. And now we can see that these will cancel, and so we do have x, which is what we wanted. Now there won't be any background noise. I got rid of some people that were in the classroom. Sorry again. So here, now we're going to do g of f of x. We also have to make sure that equals x, by the way. So g says x plus 7. And then in x is going to go x minus 7, since that's f. And once again, it does equal x, which is what you wanted. That's how you verify. Now, I know number 8 seems a little bit more complicated because of those fractions, but I assure you it's the same thing. The math and the computation is just more difficult, but nothing you guys can't do. So for number 8, we're doing the same thing, f of g of x first, and your goal is for that to equal x. So we write f first. F says 2 over 5x plus 1 over 3. And then in x, we're going to put g. So this would be 2 over 5, and in parentheses, we're going to put g. So g is 5 over 2x minus 5 over 6. And then bring down plus 1/3. So here, 2/5 times 5 over 2, that's just 1x, right? And now when we distribute 2/5 to negative 5 over 6, that's negative 10 over 30, right? Because we multiply the numerator to the numerator, denominator to the denominator, and that will just be negative 1/3. And then bring down plus 1/3, and it does equal x. Yay. And now we're going to do it the other way around. So now I'm going to erase this, and we're going to do g of f of x this time. And same thing, we want it to equal x. So g of f of x now. So g gets written down first. That would be 5 over 2x minus 5 over 6. In this x, we're going to replace it with f. So that would be 5 over 2 times f, which is 2/5 x plus 1/3, and then bring down that minus 5, 6. So this would be x. When I multiply this times 2/5, right, because reciprocals, that always equals just 1. We don't need to write 1. And then 5 over 2 times 1/3 would be 5 over 6, which does not reduce. These cancel, so it does equals x. Yay, we are done. Okay, now number 10. Find the inverse. I'm going to just write down here. So I'm going to first change this to y, as you guys hopefully remember that. Just makes it easier. Then I'm going to switch the x and the y, so that would be x equals 3y plus 10. And then you're just solving for y, so subtract 10, subtract 10. All right, so that would be 3y equals x minus 10. So what I did there was I just moved the 3y first, just because I like how that looks better, and then divide the 3 to each term. So that would be y equals x over 3, or 1/3 x minus 10 over 3. Remember that this notation needs to be with the f inverse notation. All right, and that's your final answer. Okay, we have one last problem left in this video to go over, which would be number 13. Use the horizontal line test to determine whether the function, whether the inverse of f is a function. So the first thing I want to do is graph this guy, y equals 2x plus 1. I'm going to use slope-intercept form, or you can make a table, or you can use Desmos. So the slope is 2 over 1, and the y-intercept is 1. So I would start at 1, and I would go up 2 to the right 1, and I would make a graph. The horizontal line test says draw a horizontal line through any part of the graph. So we could draw a horizontal line here, or we could do one here. Notice that your graph is only getting touched one time anytime I draw a horizontal line. So it only touches once at a time. That means that it passed the test. So it passes. And so it says here, determine whether the inverse of f is a function. You would say the inverse is a function since it passed the horizontal line test. And that's all I have for you.